Alright, here's part 2 of lesson 1 video. This is graphing to solve, solving quadratics by graphing. So the values of x that solve a quadratic are called the solutions. So we review that with solving by factoring. So when you solve the quadratic, you just get the solution. Now these are often called other names. The solutions can also be called the roots or the zeros of a function. As well, because when we plug them in for the function, they cause it to equal 0. The root comes from the fact that when we solve the quadratics, it's going to be a particular feature of the graph, which we'll see here in just a minute. So let's look at example 2. We're going to factor to solve. Just quickly review the top part here. So when I solve that, x squared minus 2x minus 3, that's a trinomial. This is a quick trinomial because you should hopefully remember that you can factor that. Two numbers that multiply to negative 3 and add to negative 2 will be negative 3 and positive 1. Okay. When I set each of those factors, so if I'm solving this, I set it equal to 0, and I set both of those factors equal to 0, I would get two solutions. One would be positive 3, and one would be negative 1 when I solve. So those are my solutions using the method from part 1. Now it says using your graphing calculator, let's graph this function on the grid, and then let's make a connection here. So on my graphing calculator, I'm going to type in the original function, x squared minus 2x minus 3. And go to your table. And when you look at the picture, this is what it's going to look like. I want to plot as many points on my paper that will fit on the graph. So it looks like I could probably plot from negative 2 to 4. So if you don't have your calculator out in front of you, pause the video and write those points down on your table. Alright, so here's the table copied down. Let's plot these points then really quick. Negative 2, 5, negative 1, 0, negative 3, negative 4, negative 3. And that's my quadratic. So there, I graph it. Now, the question is, what's the connection between this graph and the solutions I found in green up here in part 1? Well, when I look at the graph, I should notice that the solutions here, negative 1 and 3, they are the x-intercepts. That's the connection. The solutions that you get from graphing are the x-intercepts of the graph. That is why we also call them zeros or roots. Roots are where you cross the axis. All right, flip your page. Let's do a little bit more with the calculator here. Almost done. So the x locations on any function where the output is equal to 0 when they're known, they're called the zeros of the function. They just happen to be the x-intercepts. So all of these words are having a connection here. So let's graph the function x squared plus 5x plus 3 now on our calculator. Okay, and I want to notice one other thing here on the table before I move on. For the last one, the negative 1 and the 3, notice that their y values were both 0 because that's where they cross the axis. All right, so this time I'm going to graph x squared plus 5x plus 3. So here's my graph, and this time it does not look like those go through. The x-intercepts are a nice whole number. So it might be a nice decimal, but right now it's at least not a whole integer. So between what two x values do these zeros fall at? Well, the left one looks like it falls between negative 4 and negative 5. So I would say between negative 4 and negative 5. And then the other x-intercept falls between negative 1 and 0. So we have some kind of decimal in between those two whole numbers. So can we solve by factoring? Because that's going to help us out here. Well, I need two numbers that multiply to 3 and add to 5. 3 and 1, no, I can't solve by factoring. This is prime to factor, but there are still x-intercepts. So let's find the x-intercepts using our calculator. We did this on our summer assignment, so hopefully you remember, or at least have, once I show you, will remember. We're going to go to second trace, and we're going to trace number 2, which is the 0 of the function, the x-intercept. So let's start on the one all the way over here on the left. This cursor, I need a left bound, which on this left guy is above the axis. You hit enter once. Now you need a right bound, so your cursor has to go on the other side of the x-axis. Hit enter, and then guess. That is a negative 4.303. Let's go to 3 decimal points. All right, that's definitely not a nice number. So let's find our other x-intercept. We have to start over, second trace, number 2. So this time the left bound for this right x-intercept is a little below the axis. Hit enter. Now we go a little bit above, enter, and one more time. So that makes it negative 0.697. All right, there are our roots. Now notice that we could not factor this quadratic, and the roots were not nice numbers. These are irrational numbers. And that's going to play a big connection as we go through the unit. But the roots were irrational, so we could not factor it, and we had to use our calculator. I'm not going to worry about graphing it because I think you guys know how to graph it. So here's our big idea. Graphing a function to find its zeros or roots or x-intercepts is very helpful when the quadratic is impossible to factor. So when the quadratic is prime, for now, we are going to use our calculator to solve it. All right. Number 4. Solve negative 3x squared minus 14x plus 5 by graphing. So we're going to type that just like the last time into our calculator. So negative 3x squared minus 14x plus 5. Hit graph. All right, now I cannot see the top of the graph. That's okay. We can change our window. We know how to do that. Let's change our y maximum. Let's change it to 20. Go by 2s. That way we can at least see. Oh, can't quite see it still. 25. Yeah, that's better. All right, so now I can see my x-intercept. So let's trace. Second trace. Second trace. Number 2. So I'll go to this left one over here. So this time with this parabola being upside down, the left bound is a little under the axis. I go above the axis, hit enter, and then enter a third time. So one root's at negative 5. Okay, so I have one root at negative 5. And let's trace the other guy here. So this time my left bound for this root is going to be a little bit above the axis. So here's on the left, hit enter. I go a little bit below the axis, hit enter, and then 1/3 time. So 0.3 repeating, that is 1/3 as a rational number. So here, based on the nature of those roots being rational, could you factor this quadratic? Well, theoretically, yes. I just said up above that if these were irrational, I can't factor. So if they're rational roots, I should be able to factor. So let's see how that would work. Let's see if we can factor negative 3x squared minus 14x plus 5. So I will pull out the GCF of negative 1. I don't like factoring when there's a negative in front. So I'm going to pull out a negative 1 here. Just going to change the signs. But now we should be able to see that we can split the middle. So I need two numbers that multiply to negative 15 and add to 14. So 15 and negative 1. Great. So when I'm going to keep that negative 1 out in front. I split the middle here, 3x squared plus 15x minus 1x minus 5. And now I'm going to group first two terms and the last two. So unfortunately, I still have that negative 1 out in front, but here my GCF is 3x times x plus 5. Pull out a negative 1 for the next term. And I'm almost there. So this negative 1 just still kind of hangs out in front. My factors are 3x minus 1 and x plus 5. Now, if I set those equal to 0, so I could factor it, that's good. So I could factor it. Now, if I set those equal to 0, remember, this negative 1 doesn't have an x. So I don't have to set that factor equal to 0. I do have to set both factors that have an x Now on this left one, if I add 1, I'll get 3x equals 1. Divide by 3, I should notice that 1/3 was one of the roots that I found up here. When I solve the other guy and I subtract 5, x equals -5, that was the other x-intercept I found up here as well. So because I had rational roots, it was possible to factor that quadratic instead of using your calculator. All right, last one. 3x squared plus 3x minus 4. Let's graph this. All right, 3x squared plus 3x minus 4. So let's graph it. They're not at whole numbers, but they could still be nice decimals. So let's trace our zeros. So my left bound here is going to be a little bit above. Hit enter. Go a little bit below. Negative 1.758. That does not seem super rational to me. But we'll try the other one. So the last root here, second trace again. So this time I'm starting below the axis. Hit enter. Go above the axis. And 0.758. Again, doesn't seem rational here. But let's see if we can factor it. Those look irrational, so I don't think we can factor it. But let's try. I would need to find two numbers that multiply to -12 and add to 3. Like 1 and 12, 2 and 6, 3 and 4. There's no way those can add to 3, so you cannot factor that quadratic. All right, last problem. Number 6. Given you a graph, what are the roots here? Well, the first root's at x on the left, x equals -3. And the other root here is at +2.
Jenna Riley, if you're in the building, please come to the front office.
All right, so based on the nature of the roots, is this quadratic function factorable if we knew the equation? And the answer there is yes, because those are rational numbers. So we're going to come up with the equation that you could factor for that quadratic. So we actually have to work backwards here. Now I want you to think back to this problem, example 4. We found our answers, the roots from graphing, right? From factoring as well. So when I have these guys, these roots, they came from factors that look like that. So somehow I have to figure out the factor that the root came from. Now I'm going to look at this right one real quick because this is actually easier to see the pattern. If my answer is x equals -5, notice that the root is x plus 5. It is the opposite sign of the -5. And it is, even though it's a fraction here, you can still see this 1/3 was positive, its factor was negative. So what I'm going to do is to create this, I need to come up with the two factors that I multiply together. So if I had an answer of x equals -3, that means it came from the factor x plus 3. All right, so if you need to see it like this, you need to move that -3 over here. Right, you want this side to be 0. So you would have x plus 3 equals 0. X plus 3 is your factor. Same thing with x equals 2. In order to get the factor, I have to move the 2 next to the x. So I would subtract it and make it x minus 2. Okay? That is the factored form of your quadratic. We want the standard form. Right? Standard form means no parentheses. So I would FOIL here. X times x is x squared minus 2x plus 3x minus 6. Combine these like terms, and that's the equation in standard form.